I decided to make this video after watching some channels where mathematicians solve the problem from one math Olympiad, but they all solved it the same way and quite strange. The problem is simple. Calculate the value of this expression. All speakers chose the direct solution. They all got the correct answer, but I am surprised that no one suggested a more elegant solution, which, however, requires some additional knowledge of mathematics. I'll tell you now. Let's take a look at this expression again. In fact, the golden ratio is written in brackets, and the golden ratio is associated with such a famous sequence in which the first two numbers are ones and each subsequent number is the sum of two previous ones. For example, the third number will be equal to 2, since 1 plus 1 is equal to 2. The fourth is 1 plus 2 is equal to 3, and then fifth 2 plus 3, which is equal to 5, and so on. This sequence is called the Fibonacci sequence, and in fact, each number in this sequence can be directly calculated using a formula called the Binet formula. It looks like this. It contains the golden ratio 1 plus square root of 5 divided by 2. It can be used to calculate the golden ratio to the 12th power. So in our case, n is equal to 12. So let's write 12 instead of n. And the 12th Fibonacci number is 144. Here, however, there is a second bracket in which we have 1 minus square root of 5 divided by 2. But this is not a problem, because we can use the following equality. It is obviously correct. You can mentally open the brackets. The numerator will be difference of squares, and we get minus 4 divided by 4, and this is minus 1. So from here, we can express the second bracket. It will be equal to minus 1 divided by the first bracket, and substitute it here. Since the power is even, the minus sign disappears, and we get the following expression. Let's rewrite it and denote the desired expression as x. Then we get the following simple equation. Multiply both sides by square root of 5 and by x squared, which is not equal to 0. As a result, we get the following quadratic equation. All that we have to do now is to solve it. The discriminant is equal to this number. We need to calculate the square root of it. We can make an estimation as follows. Forget about 4 and replace the square root of 5 with 2.236. Then we get the following number in brackets, which is almost 322. You can check it without calculator that 322 squared is indeed equal to the discriminant. Then the first root of the equation is equal to the following expression, and the second root, according to the Vieta's theorem, is negative and doesn't suitable. So we had the final answer. As you can see, sometimes it is useful to know a little more than the school math program gives. That's all for today. Thank you for watching and for your donations. See you in the next video.